those inner ear cells the same. I try to take better care of them now that I know this, but I like my earbuds just like everybody else does. So that's all right. But that is how we produce sound, which is kind of cool. This other part, equilibrium. Okay. Whoever was in lab that day, they got very inventive with the names. Okay? They were very imaginative. I will say, I don't know what these terms stand for. Okay? What they're going to be referring to. All right, so now that we know about the cochlea, the rest of it over here, the semicircular ducts, okay? We're going to find that this vestibule area, this area right here, the structure of it, the way that it is oriented, okay, they gave it very interesting names. But what do you notice about the orientation altogether with these semicircular ducts? If they're sitting in the ear like that, okay, and I pick it up, what do you notice? One points up, one points to the side, and one kind of going around. All right? Now remember, these semicirculars and this little vestibule are fluid filled also. Okay? So, in this understanding of equilibrium, all right, we're going to find that vestibular apparatus structure, okay, and it's going to have receptors for equilibrium. We've got our semicircular ducts that are present, and in this vestibule we have two chambers. Anterior they call saccule, posterior utricle. Right, well, we're going to look at a picture, okay? Our equilibrium, we're going to say that we have static or dynamic. In the grand scheme of things, if somebody says something is static, they're pretty much saying, oh, it's not moving, it's just there. If they say it's dynamic, it's something in motion. So, static, based on our inner ear, static equilibrium simply wants to know what is the orientation of our head. Up, down, side, side, twirl, tumble. Does that make sense? Okay. Dynamic. Well, what is the motion that's happening? Is the body as a whole moving up or down or side to side, front to back, twirling, tumbling? Now, is it moving? Is my body as a whole moving up, down, side, side? Are y'all seeing my semicircular ducts? Okay, so is my body as a whole making some of these motions? So now we're going to have to try to figure out, well, what is it? Is it front, back, side, side, blah, blah, blah? All right, and then what do I need to do to make sure the rest of the body catches up? Is in understanding of that position. For example, do any of y'all, like if you have to, like say, okay, since we're on the 6th floor here for the elevators, on the 1st floor, when you get on the elevator, come up to the 6th floor, when you get off the elevator, do you still feel like it's like you're on the elevator for a second?
I feel like I'm on an escalator.
Okay, and I don't like escalators. Ooh, no. I can go up, okay, but I think it's something about when you got to go down, and I see my eyes are seeing it move, and my head's trying to figure it out. I don't like it. But okay, ocean, like the movement of the waves and stuff. And after you get out, you still feel okay. And that's when you might, as you try to walk out the waves and stuff, lose a couple cool points because you fall. Yeah. Okay. So you got, you've got these situations where it takes a second for everything to sort of catch up. I'm going to explain to you why that happens. Now, the problem is when things go wrong and people can't recover. Like people who have like inner ear, Meniere's disease. Ever heard of something like that? Okay. So, and they're constantly feeling as if they don't have their equilibrium. Okay. That could be bad.
Does this go into play with like vertigo and
Yeah, people they can have really severe episodes of it, sometimes to the point where they have to go to the hospital, get medication, all this sort of stuff. Other times it can be something that's not as severe. They just might feel a little wobbly and stuff like that. And there is an actual disease that goes with it called Meniere's. And, it's lots of things that can happen to it. But the goal, and this is one of the reasons that I think they have put it with being a special sense, is because of what they've learned, what happens in these parts of the ear. So, our saccule, our utricle, our macula. Now, macula, this is, when you hear this term, let yourself think of a mass, okay? Because what it is, a patch of cells, okay? We're going to find some hair cells and supporting cells, and we're going to find one in the saccule and the utricle. And their job, understand if my body is vertical or horizontal. Okay? So in the structure that we have, okay, so my vestibule, that little area before you get to the semicircs, all right, we have a portion anterior, posterior, okay? We have the connection to the vestibular portion of that vestibular cochlear nerve. So now I've got the vestibule portion in my anterior, my posterior, okay? I've got my saccule and my utricle. Here's my mass, my macula, okay? And we've got the one that deals with vertical and the one that deals with horizontal. So the cells that are going to make that up are going to help us determine that orientation. This way or that way, okay? Laid out. Think about going to sleep, okay? We are then horizontal. So we're now looking at, they still term those little cells, okay, stereocilia, but each one is going to have a true cilium, and they call that kinocilium. But in the grand scheme of things, once again, we are in a gelatinous material. Once again, think about the Jello that's thawed out, and we call it otolithic. In this area, the reason we say otolithic is because it has otoliths. In layman's terms, these are little bone crystals. And when they first started learning about this, they literally referred to them as rocks, because that's how they kind of looked with the visualization we had at the time. And what they are is little tiny bone crystals. All right. Now, if I have those, the best term to use is rocks. Okay. So if I have embedded in that gelatinous material the rocks, okay, these little crystal parts, and then in my makeup of the cells, I've got my, you guys see support cells? The reason I point that out, anytime we talk about nerve cells always have support cells. Do you guys remember glial cells? Okay, they always have support cells. And then you always have your true cell. What do you notice about their cilia? The cilia is in that gelatinous material, and in that gelatinous material are the otoliths. So now, if I am thinking about vertical or horizontal, what do you think the rocks, these little crystals, will do? They'll move. So in that gel, if we talk about up or down for vertical, well, guess what? Rocks will go up, they will come down. Horizontal, side to side. And as they move, they get to push on the cilia. And the cilia create the action potential about that movement of either being vertical or horizontal. Does that make sense? This is the part where people who may have the vertigo, the dizziness, the difficulty with their equilibrium, and what they are finding out, physical therapy can actually help people with the vertigo. So if they have a very severe case, they have found that, now granted, they have to be able to put your body into some really crazy positions, but if they can go in and cause